Hello, this is CSE 102 Computer Programming course offered at Department of Computer Systems Engineering, University of Engineering and Technology, Peshawar, Pakistan. This is lecture number 1, Introduction about Computer Programming. I am Dr. Muhammad Athir Javed Sethi. So what is computer programming? Computer programming refers to a set of instructions required to solve a particular task, particular problem in a computer, or set of instructions required to do useful tasks. The course code is CSE 102. The course name is Computer Programming. It is a three credit hours course. The group address is mentioned in the slide and the class code is N6EP54H. You need this class code to enter this Google Classroom. This Google Classroom contains all the course materials which include lectures, handouts, assignments, quizzes, and other relevant materials. So why we need a computer language? As we all know, computer only understand machine language, which is the form of zeros and ones, which is very difficult to learn, difficult to program, cumbersome to memorize the sequence of bits or zeros and ones, and it is very difficult to write a big programs. Therefore, programmers devise a way how can we program the machine or computer in a human understandable languages. So in the coming slide we will discuss the levels of the languages. So as you can see in the slide that in the main memory all the data and program are stored in the form of zeros and ones. The CPU, the central processing unit, process the data and instruction in the binary. CPU process data and again stores the data in the main memory in the form of bits. So there are three levels of the programming languages: machine language, low level language, and high level language. Machine language is in the form of zeros and ones. It is hard to read, slow to create, and fast to run. Fast to run because it is in machine language. Machine directly processes it, while it's slow to create and hard to read because it's the sequence of ones and zeros. So difficult to read, difficult for the programmer to create a program in it. Next level is a low level language. Usually it is called assembly language. Assembly language contains mnemonics, which also called as memory aids, easy for the memory to memorize the code. For example, move A 90 hex is an instruction in which 90 hex is moved in A. Increment A means increment A by 1. Jump if not zero loop means if the zero flag is not set then jump, and so on. So these are some terms of English like words, human readable, but not all. Still it's slow to create, fast to run, as it is a processor specific language. Different processors have different assembly languages. So as we know that machine only understand machine language, so we need a assembler, we need a compiler, we need an interpreter. In the case of assembly language, it is called assembler, which converts the assembly language to machine language, so that machine can run the code. Next is a high level languages, which is the examples of Pascal, C, Fortran, C++, Java, Python, R, MATLAB. These are high level languages. Human understandable, fast to write, but sometimes slow to run on the machines. But nowadays there are multi-core systems, so we do not see the delay in the processing. But still, it takes time for the high level language to convert to the low level language, to the lowest level, it is machine language. And usually one statement in a high level language is equivalent to many machine level codes. So we will study in this course C++, which is high level language. Um, so on the left side of the slide you can see a high level language code, which is C++. In this code we are printing hello world on the screen, and the compiler and linker translates this high level language code to the machine language code. So how it works? As you can see on the flowchart, the sequence or the steps in the compilation of C++ program, we have a code in C++. The preprocessor directive directs the compiler to do certain tasks which are required to compile the code. The compiler then compiles the sequence of instruction in C++ If there are no errors, that obj file is created. If there are some errors, we have to go back to the editor and again change the code. The linker will link the library built in to have a built-in functions in the code. If there are no errors, .exe file, which is in the form of binary, will be created. If there are errors, we have to go back and change the code again. So every C++ program must have these three parts. The preprocessor directive, which starts with a hash. For example, in the code you can see hash include iostream is a preprocessor directive which directs the compiler to include this library, which will be linked in the linker step. The main function, the program execution in C++ program starts from the main function. Even though if you have 1000 functions in the C++ program, the compilation will start from the main function. And every main function, every function in the C will have C++ statements. So what are these? Let's go one by one. As I said before, this code prints hello world on the screen because cout is a built-in function. Cout stands for console output, which is a built-in function in iostream.lib file. So that prints hello world on the console. Console means screen, our monitor screen. Hello world, as you can see in the example hello world, the hash include iostream means include standard input output library so that we can use input output functions, for example cout, and we read it as hash include. Main function, every C++ program must have a main function. As I said before, every block of code starts with the left curly brace and ends with the right curly brace. That shows the block of the instructions, block of the code. This is an instruction call, and this is an instruction, and we are calling a function which is called cout, and we are printing hello world on the screen. Every statement ends with a semicolon in C++ program. So in the coming lectures we will study the pattern and different syntax of C++ language. So let's just summarize it and do a simple example of hello world in on our code blocks software. So usually C and C++ software, C is a sub C and C++, they are high level languages. C is usually a subset of C++, as C is a structured language, while C++ is object oriented programming language. The extension of file in C is C.C, while C++ is .cpp. In the lab or in the class, we will use CodeBlock software. It's open source software. You can download the CodeBlock software from the link provided on the slide. So these are the few terms which will be used in this course. Source code. Source code is the actual code which you write. In our case, it will be .cpp file, the code in C++. The compile build is a process which converts the source code to a machine language code. The executable file is a .exe file which will be run on the computer. Library, we add library using uh, hash include preprocessor directive to use certain built-in functions. Header files are .h files which are included at the start of the source code. For example, hash include iostream.h. So let's just do a small example of hello world in the CodeBlock software. We are using 16.01 version, so you can use anyone, but make sure that you download the Ming setup because it contains the C++ and C compiler. Go to file menu, click on new, click on file, select C source. Let's name the file as my hello world. The extension will be .cpp, so no need for writing .cpp again. hash include. These are p processor directive, IO stream, no need for that h file. In different compilers, in different editors, we need sometimes we need iostream.h. In code blocks, we don't need to put .h. We will in the coming lectures we will know or we will learn why we write return 0, why we write return, what is int, what is this main, can we write our own functions, what is the difference between built-in function and user-defined function. We will cover all these topics in coming lectures. So this is our first program, hello world, which will print hello world on the screen, on the console. Let's just build it and run it. So so you can see hello world is printed on the screen. When you press any key, the program is closed. One thing I want to show you that two files are created as we saw in the flowchart. .obj file is created and .exe file is created. As you can see, my hello world, this is the source code, this is the object file .obj file or .o file, and this is .exe file. Let's see it. Right click, go to properties. You can see it's obj file or .o file, which is an object file, and this is .exe file. So that's it for this lecture. In the coming lecture, we will learn advanced concepts about C++ computer programming, and we will also have hands-on experience.